Hello and welcome. So today we're going to be talking about what is API Flow. API Flow is a reactive API framework designed to simplify the creation, deployment, and scaling of REST APIs using a Spring Boot WebFlux. It is built on reactive programming principles to handle high loads efficiently using non-blocking I/O and asynchronous processing. Key features: reactive and non-blocking, utilizes a Spring Boot WebFlux to process requests asynchronously using Mono and Flux, resulting in efficient resource usage and improved scalability. Template-driven approach provides a pre-built structure for controllers, services, repositories, and models. This reusable foundation enables rapid development and customization to fit different API scenarios. MongoDB integration, designed to work with MongoDB for non-relational storage, making it easy to manage unstructured or semi-structured data while maintaining high performance. Containerized deployment, built with Docker Compose in mind, allowing API flow and its dependencies like MongoDB to be containerized for consistent and portable deployments across different environments. Security via OAuth 2 secures API endpoints using OAuth 2. Client credentials flow, ideal for machine to machine communication. This ensures that only authorized systems can access the API. Comprehensive documentation integrated with OpenAPI via SprintDoc to automatically generate interactive API documentation, making it easier for developers to understand, test, and integrate with the API. Benefits: high performance. Non blocking reactive architecture allows API flow to handle thousands of concurrent requests without thread exhaustion. Modularity and flexibility. The template-driven design encourages best practices and clean code, making it easier to extend and maintain as requirements evolve. Easy of deployment. Containeriz- con- container containerization containerization with Docker Compose streamlines development and production deployments, reducing configuration overhead. Future future proof, designed to support additional advanced features like real-time streaming, caching with Redis, and potential AI optimizations for API performance. Use cases: when building scalable REST APIs for microservice architectures, creating API gateways that require high throughput or low latency, rapid prototyping of new APIs with robust production-ready foundations, integrating with various data sources, particularly non-relational databases like MongoDB. Okay. API Flow serves as a comprehensive starting point for developers who want to build high-performance APIs without reinventing the wheel, while also providing the flexibility to extend its capabilities as needs grow. I just asking another question there. I wanted to see if we could use Payload for this type of application, but I will be using. We'll stick to this. Yeah, I will not go over this for now. Let me go. So let's generate the next lecture. Actually, we want to copy this content. I think we already did, right? Oh no, we maybe we didn't do yet. Upload some of these windows API flow. So this will be the first lesson. What is API flow? So we covered that. Now we go into the next section. Why workflows? Understanding reactive API development. Reactive API development is centered around non-blocking, asynchronous processing, which is essential for handling high loads and ensuring efficient resource usage. Core concepts: reactive strings, built on the principles of publisher, subscriber, subscription, and processor, provides a standard for asynchronous string processing without non-blocking back pressure. Mono and Flux. Mono represents a string with zero or one element, ideal for single result operations. Flux represents a string with zero or many elements, suitable for for handling multiple data events over time. Non-blocking I/O. I still need to, okay, represents a string with zero or many elements. Yeah, I understand that part. It could be more than zero to as many as possible. Suitable for handling multiple data events over time. Okay. Ideal for single result operations. We need to understand exactly with examples what is the difference, I would say. And I guess we might get to look at that. Let's see. Uh, are we in this course are going to get to see examples? Do we have in the table of contents some examples that will go over single result operations and handling multiple data events? Basically, the difference between Mono and Flux. Can you generate a table to explain that, maybe with a small example, or what do we mean exactly? What is the main difference of those two? Okay, so we will get back to that. Non-blocking I/O. WebFlux uses non-blocking I/O to process requests, which means threads are not held up waiting for input-output operations like database calls or external API requests to complete. Everything occurs, everything just keeps flowing. It doesn't stop. This enables the ecosystem to handle many concurrent requests with a small number of threads. Yeah, so with a small number of threads, it still can manage many requests concurrently. Benefits of reactive programming with WebFlux: scalability, handle thousands of simultaneous connections by efficiently utilizing system resources. Responsiveness improves latency by not blocking threads during input-output operations, which means faster responses under high load. Resource efficiency uses event loops and asynchronous processing to minimize the need for large thread pool, reducing overhead. Analogy: imagine ordering a pizza online. Blocking, traditional approach. You go to the restaurant, you place your order, and wait for that at the counter until the pizza is ready. While you wait, both you and the restaurant staff are idle. Non-blocking, reactive approach. You place your order online, then leave to do other things. The restaurant processes multiple orders at once without making you wait at the counter. You receive a notification when your pizza is ready, allowing you to pick it up without being idle. Why choose WebFlux for API flow? Concurrency efficiently handles many simultaneous API calls, ideal for microservices and high traffic scenarios. Asynchronous processing. The reactive model ensures that operations, that is to say, database queries, external APIs, are processed without blocking, leading to better overall throughput. Improve developer experience with concise and clear APIs. Mono and Flux reactive programming simplifies error handling and strings transformations. In summary, WebFlux empowers API flow to deliver high performance, scalable REST APIs that can gracefully handle heavy loads and provide a responsive user experience without wasting system resources. Wait to the question I asked before gets generated in my phone, then I'm gonna just reload it here so we can view it, the large screen. something else. Why WebFlux? Understanding reactive API development. We took a look at this. So now it's this. So we ask, are we in this course are going to see examples? Do we have in the table of contents some examples that will go over single result operations and handling multiple data events? Basically, the difference between Mono and Flux. Can we generate a table to explain that maybe with a small example, or what do we mean exactly? What is the difference between of these two? So number of elements. So it's from zero to one element, zero to many. That's a major different explanation. Mono represents a single result, and none or none. Webflux handles a stream of data. Okay. Use case, a single response, that is to say, fetching for a user by ID. Multi-response, that is to say, streaming a list of users or continuous events. Choose Mono for one-time results and Flux for streaming or collections. Okay. Error handling, emits a single error or completes without emitting data. Can emit errors at any point in the string. Okay. Both have robust error handling, but Webflux errors can occur in the middle of the string. Back pressure support not applicable since there is at the one element. Then there is as most one element. Supports back pressure to manage data flow efficiently. Flux can signal the producer to slow down if the consumer is overwhelmed. Flux can signal the producer to slow down if the consumer is overwhelmed. Example code snippets, mono example, single result, mono string, mono example is equals mono just, hello, API flow, mono example, subscribe, result, system output the print mono result, and then it will output this. This will output a single value, hello API flow, flux example, multiple results, flux string, flux example, flux, yes, hello, reactive, word, flux example, subscribe, resolve, system output the print, flux. So it reads, so I guess this is what you're trying, I guess what this is saying is that you could receive multiple inputs, kind of like that. And this one is a single. This will output each value in sequence, hello, reactive world. Okay, just keep going. So the first step is going to be setting up the environment, Docker first. Docker and Docker Compose as essential tools to containerize. Is that how you pronounce it? Let's go check it out. Containerize. Containerize. Container. Containerize. 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 Nar. Containerize. 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 Or whatever. It's a terrible app. Okay, setting up the environment. Docker and Docker Compose are essential tools to containerize our API flow application and its dependencies like MongoDB for consistent and portable deployment. Installing Docker and Docker Compose. Docker, this actually pause right there.